The first part is remembering how to simplify radicals, okay, without any decimals, just to simplify, okay. So if we look at number 1, how do we simplify the square root of 32? What do we end up getting? Yeah, Mia. 4 root 2. We look for, if we can, perfect squares, okay? Square root of 16 is 4, then we're left with 4 root 2. We can't do anything with the square root of 2, so that stays the same. How about number 2, square root of 80? Any ideas? Or what 2 factors did you start with to simplify? Nick? 8 and 10, okay? And then we could keep going. And since it's a square root, we're looking for pairs of 2. 2 means pair anyway. Here. So remember, every time I break down, I am crossing out, okay, and looking for a pair. So I have a pair of 2's. A 2 comes out. Another pair of 2's. 2 comes out. Whatever's not circled or not a pair stays inside. And then we just multiply whatever's together on the outside, okay? You could have also done root 16 times 5 to get 4 root 5 as well, okay? All right, number 3, can we have a radical in the denominator? No. How do we get rid of it? Camilla? Yep. Okay, we multiply top and bottom by the square root of 5. So we have the square root of 5 over 5 as our final answer. Okay. Number 4 looks very similar. However, what can you do first? Is there anything? Yeah, Finn. Good. So 6 over 3, we could simplify that to 2 over 1. So we have 2 over root 7, and doesn't it look familiar like the last one we just did? Okay, if you kept it as is, you would just multiply top and bottom by root 7, then reduce. Okay, so from here, multiply top and bottom by the square root of 7, so we're left with 2 root 7 over 7 as our final answer. Okay, any questions about 1 through 4? Okay, and again, this is recalling because we've seen this already. Yeah. 1 through 4. What is the square root of 5 times square root of 5? What's the square root of 25? Okay, so when you multiply a radical by itself, you're left with whatever's inside. Okay, good question. Number 5, what is that an equation of? Okay, it could help us find the hypotenuse. What else? Yeah. Good. It could be used to find any missing side length. Anyone remember what that's called? Yeah. The Pythagorean theorem. It's the Pythagorean theorem. You could find it any side length. However, C represents what? The hypotenuse. C represents the hypotenuse. A and B are your side lengths. Okay? C is your hypotenuse. Yeah. The triangle needs to be right. We have seen it a lot for right triangles. What do you guys think? Is it only used for right triangles? It could be used for any. Okay? Now, 6 through 9. What do we do here? What do we have to do? Anyone recall this? Yeah. Cross multiplication. Good. So we multiply 2 times x plus 1 equals 4 times x. Okay? Multiply 2 times x plus 1 and multiply 4 times x. On the left-hand side, what do we have to do? Distribute. Okay. And we have to solve. So what do we have to do here in order to solve for x? Yeah. Divide both sides by 2. Good. So we end up with x equal to 1. Okay? So we have a proportion on either side. So from here, we have to cross multiply. Okay? So again, some of you left this part blank because we weren't sure, okay, what to do. So I'm going to give you about a minute or so, minute and a half, to go through 7, 8, and 9 if you haven't done so already. Okay? If you did, just double check your answers. 7, 8, and 9. All right. For number 7, Tyler, what do we have? Okay. So when we cross multiply, 3 times 2x minus 1 equals 6 times 5x. Okay, we distribute. Okay, we have 6x minus 3. We subtract 6x. Negative 3 equals 24x. Divide by 24. X equals, and we can reduce that to negative 1/8. How many of you did get negative 1/8? Good. Okay. Now looking, we're still on the front page, Anthony, please. Now looking at number 8. Finn, what do we get for number 8? Careful the order. You have the right numbers. However, it's 68 over 5. Okay? So we have 22 times 3, 66, 5x minus 2. We add the 2 to the other side. $68 over 5. Right? Yeah. Nope. You can leave it as is. Okay? Yep. That could be reduced. Okay? That could definitely be reduced. All right, number 9. Emily, what do we got? Emily of B. Sorry. Good. Negative 5 over 16. We have negative 16x equals 5. Divide by negative 16. X equals negative 5 16ths. Good. Excellent. Okay. In the last piece, we should remember what this is. Okay. What is it? Yeah. Okay, good. You can find any side, oops, or angle, okay, using our trig ratios, okay? What does the S stand for? Sine, what does the C? Yep. Cosine and T? Tangent, okay? So we are going to see these trig ratios again today, okay, to recall, right? Any questions on this first page? Okay, that was just to recall a lot of the information you have seen before, okay? Let's turn the page. All right. The word trigonometry means triangle measures, and that's the whole idea of what we're going through today, okay? We're going to study the relationship among sides and angles of triangles. Again, a lot of recap, okay? But in the back of the brain, we got to move it forward. In geometry, you investigated the 3 trig functions, which we just mentioned: sine, cosine, and tangent. There are 6 functions. We are only going to stick with the 3, okay? When you move on to higher maths, if you do, you will investigate all 6 functions, okay? We are only going to look at these 3. In a right triangle, you can find the missing side lengths and angles using right angle trig, all right? So our special rates are also going to come in a little bit later. Recall SOHCAHTOA, we have sine. What does O over H mean? Camilla. Opposite over hypotenuse. Good. What does A over H mean? Nick? Good. Adjacent over hypotenuse. And then O over A is just opposite over adjacent. Okay, so we will be looking at our sine, cosine, and tangent in terms of right angles. Okay, all right, so we're first going to look at angle A. Okay, so angle A is right here. That's angle A. All right, across from angle A is your opposite. Right next door to angle A is your adjacent. Okay, always across from your 90-degree angle is your hypotenuse. Okay, so if I wanted to know the exact value, yes?
How do you know A or B?
Sine of A.
Yep, for the triangle. Yep.
So here is angle A. Across from it is your opposite. Okay, right next door is your adjacent, right next to it. And then your hypotenuse is always across from your 90-degree angle.
So that's just counted.
For angle A. Yep, because it says sine of A.
Bottom one.
You're going to see it. Yep. I'm going to change a different color so you can see the difference. Okay. So using our measurements here, okay, what is the sine of A? What would that value be? The sine of A. M? 4 over 5 because it's opposite over hypotenuse. So 4/5 is your exact value for sine of A. How about cosine of A? What would the cosine of A be? Rob, what do you think? 3 over 5. Excellent. Good. Okay, and now the tangent of A. Stefan, what do you think? Careful. 4 over 3. Excellent. Good. Okay. All right. So now we're moving on to B. Yes, Mel? Not yet. Nope. Nope. Okay, so now we're looking at the sine of B. So here is angle B. So now this side length is now what? Opposite. Here's what? Adjacent, and hypotenuse is still the same. Okay, so now we're looking at the sine of B. What would the sine of B be? Chris? 3 over 5. Excellent. Good. Cosine of B, loose. 4 over 5. Excellent. Good. Okay. And the tangent of B, Porter. 3 over 4. Good. Excellent. All right. Good job. All right. So again, it will change, okay, depending on where the angle is. All right. So let's look at example 1 here to find the exact values. Right? We're using something that might be new to you. Okay. You might actually have seen it, which is called theta. Okay. Theta is, we don't know what it is, but an angle measure. Okay, we don't know what theta is, so that's what, instead of labeling it a letter, they're just calling it theta, okay? So if this is theta, okay, we're labeling opposite, adjacent, and hypotenuse. So take a minute to find exact values of sine, cosine, and tangent of this triangle. Go ahead. All right. The sine of theta, take. Okay, sine is what? How do we find sine? Opposite over hypotenuse. So if this is our angle, what is the sine? Good. 8 over 17. Good. Okay, Anthony, cosine of theta. 15 over 17. Good. Okay. Zach, tangent over theta. Good. Excellent. Good. All right. Nice job, you guys. So now it's a little bit different. What do you guys notice? What do you notice now in our next triangle? What do we see? Yeah, Tyler. We have a square root now. So we have to make sure that we don't have a radical in the denominator. Okay? So we're looking for angle B. All right? So this is opposite, adjacent, hypotenuse. So what would the sine of B look like? Finn. 4 over root 17. Now, can we have a radical in the denominator? No. So what do we have to do? Yeah. Multiply top and bottom by root 17. So we have 4 root 17 over 17 as the sine of B. All right. What would the cosine of B look like? Tyler. Excellent. It was first 1 over root 17. We have to multiply top and bottom by root 17. Nice job. And then the tangent of B. What would the tangent of B look like? Yeah, Rory. 4 over 1, which is just 4. Excellent. Good job, you guys. Okay, so given all sides of a triangle, we are able to find the missing side lengths, okay, or our trig ratios, sorry. Now we're looking at the exact values, okay? So here is our triangle, okay? And they're giving us, we're going to do right triangle and say this is theta, okay? They're giving us the cosine of 2/5, okay? So if this is theta, cosine means what? What is our trig ratio in terms of cosine? Yeah, Nick. Adjacent over hypotenuse, okay? So here's our angle, and we could have used the top too, but we're using this one. It's a little bit easier. This would be considered what side? Opposite, adjacent, or hypotenuse? Opposite. What would this one be? Adjacent, so we're going to label that 2. And then our hypotenuse is 5. But we need to find that missing side length. So what do we have to use? Yeah, Tyler. Pythagorean theorem. Good. So, all right, remember your C is always your hypotenuse, A and B is your side length. So we're going to use, let's say, A squared plus our B, which is 2 squared, equals 5 squared. Okay. We have A squared, 2 squared is 4, it's 25. now we have just our missing side length. For right now, we're just going to take the positive. Because typically when we're solving, we should have what? Plus or minus, right? But for now, we're just going to stick with the positive. Okay? So now we found our missing side length. Can you find the missing trig ratios? Sine and tangent? Go right ahead. All right. Looking at the sine of theta. Camilla, what do we have? Good. Square root of 21 over 5. Excellent. The tangent, Liam. Good. Square root of 21 over 2. Excellent. All right. Let's try one more. All right. So here is angle. Here is theta. Tangent is what? What is our trig ratio for tangent? Yep. Opposite over adjacent. So across from theta, this side length is going to be what? Opposite, which is 1. And here is going to be adjacent. So we have to find our hypotenuse. Right? So go right ahead and find your hypotenuse. Okay? Then find sine and cosine. Okay? Use above to help you out. Remember? And C is what we're looking for. How many of you did get the square root of 5? Good. Awesome. All right. What is the sine of theta? Ella. Excellent. You have 1 over root 5. Multiply top and bottom. Square root of 5 over 5. Excellent. How about the cosine? Rob. Excellent. So we have 2 over root 5. Multiply top and bottom. Perfect, you guys. Great job. Okay. Any questions? All right. So now, to find a missing side length, okay, to find a missing side length, we are given an actual angle measure, okay? So we're going to use our trig ratios and our calculators, okay, to find a missing side length, all right? So, but first we have to determine we're given this angle. What trig ratio will we use? What are the side lengths given? What trig ratio? Yeah. Cosine, because we have adjacent and hypotenuse. Okay? So, we're looking at cosine of 42 equals x over 18. Okay? So, it should look familiar from our warm-up, right? How do we solve for x without even doing anything? How would you solve for x here? Yeah. Cross multiply. So we have 18 times cosine of 42 equals x. All right. So we're going to use this in our calculator. Okay. However, we must be in degree mode. Okay. All right, we must be in degree mode, okay? So turn on your calculators. To change the mode, it's given to you, mode, just press mode. Mine's already changed, but you guys have this highlighted, radians, right? This is what you currently see, right? So go down to the third one where it says radian and degree. Highlight degree, press enter. Okay? You must be in degree mode for this to work. Okay? So then we do second quit, right? So we're in degree mode right now. Okay? So now we're just going to enter exactly what we just did. 18 cosine, here's sine, cosine, and tangent right above cosine of 42. Press enter. In here, we're going to round to the nearest tenth. Okay? So our missing side length is x equals 13.4. Okay? So make yourself a note. Must be in degrees. Okay? Must be in degrees. All right? So let's try, you guys are going to try this one on your own. However, before you begin, actually we're going to do this one together. We're given this angle. What are we using? Sine, cosine, or tangent? Yeah. Tangent. Good. Tangent of 21 equals 9 over x. So how do I go about solving? This looks a little different. Yep. Still cross multiply for now, right? So x tangent of 21 equals 9. But how do I get x by itself? You would have to divide both sides by tangent 21. Okay? So in our calculator, 9 divided by tangent, it's right here, 21. Should get 23.4. Everyone good? How many of you guys remember this stuff? All coming back? Good, good, good. All right. Now this is different. Okay? All right. Now we're going to be using the inverse because what do we have to find? We have to find theta. We actually have to find the degree. Okay? So we're still looking for our trig ratios. However, if you look at your calculators, sine, cosine, and tangent, what is right above it? Do you see these notations? Yes. To get those notations, you would do second whatever sine, cosine, or tangent. Okay? So we need to find theta. What trig ratio would we need here? Nick. Tangent. So we're going to use the inverse tangent of what? What is our ratio? So if this is theta, what would be my ratio for tangent? Yep. 26 over 11. Okay, and we're rounding to the nearest degree. So again, in our calculators, the inverse tan, second, tangent, it gives you parentheses already, 26 divided by 11, 67 degrees. Okay, 67 degrees. All right. Good. Why don't you guys try number 2? Yeah. Because here's your angle. This is opposite over adjacent. That's when you use. Okay. So number 2, what would you use? Tyler. Sine, good. The inverse sine, because here's theta, this is opposite, and our hypotenuse is given. So inverse sine 14 over 16 and round to the nearest degree. Go ahead, Finn. Correct. Yep. What's my degree for number 2? 61. Good. All right. And to finish this piece off before we get into special rates, you guys are going to try these 5 on your own. However, they're given to you a variety of different ways. So use your notes, work with somebody, okay? I'm going to give you about 5 minutes, okay? Go ahead. A through E. All right. So for number 3, for A, your setup should have been sine of 37. You must have that degree there or else it doesn't make sense, okay? Sine of 37 equals x over 10.3. What did x equal if we round to the nearest 10th? Yeah. 6.2. Good. Awesome. Okay. Now in letter B, you're finding theta. So from theta, you have opposite over adjacent, which is tangent. So inverse tan of 4 over 13, nearest degree. What do we have? Ella? 17 degrees. Awesome. Nice job. Okay. Now for C, okay, again, you're given the degree, tan of 65, A over 20. You have to cross multiply. What did we get? 43. Okay, good. How about D? Cosine of 35, B over 17. What is B? Zach? 14. Good. How about E? Luce? Sure. $33. You're finding the angle. You're finding the side length, right? So cosine of 35 equals B over 17. 17 times this. Okay, let me see what you have. Just check. Oh, you have, it's 17 cosine of 35. Okay, all right. How about E? What do we have? Rob? 5.2, good. Excellent, good job. Any questions? Yeah, Mia?
For C and D, I thought when you were finding the side length,
Was this one 42 point, I don't have it on me, so 42. Okay, good. Then you would be correct. And then this one,
that was
0.9. Okay. Yes, you are correct. Okay. Those are just so close. I think we're just in a habit of rounding, but yes, you are correct. Yes.
we're quite exactly. For example, D, like 5, 7.
Or 17, but you have to make sure if you do times, make sure you close out that parenthesis, or else it's 37 times 17. Yes. Quickly. All right. Any other questions? All right. Here we go. Our biggie. This is our big guy right here. That is going to be for this whole entire unit. Okay? This is our go-to. Okay? This is going to help fill out this guy eventually on the back. You guys don't have this, but this on the back. This is what we're heading towards. Okay? Get excited. This is my favorite unit. Get excited. Okay. Anyway. All right. So how many of you remember special rights? No excitement anywhere? Huh. Okay. All right. Fine. We have to remember this. This box is give it a big hug because that's your baby. That's what you want. That's what you want to remember. Okay? So there's two types of special rates. Our 45, 45, 90 and our 30, 60, 90. Okay? 45, 45, 90. Okay, is one of the easiest. Okay, X is your side length. So for 45, 45, 90, you have same side lengths. Okay, your hypotenuse, so across from 90, is your side length times root 2. Okay, so 45, 45, 90, side lengths are the same. Across from 90, your hypotenuse is your side length times root 2. Okay? All right. Now, our 30, 60, 90 is where it gets just a little tricky. Okay? Across from 30 is still your X, which is your side length. Okay? However, across from 60 is your side length times root 3. Across from 60 is your side length times root 3. And your hypotenuse is 2 times your side length. So 30, 60, 90 is a little bit more to remember. Okay? Across from 30 is your side length. Across from 60 is your side length times root 2. Across from 90 is 2 times your side length. Good? All right. So first we're going to look at a few examples of 45, 45, 90. Okay? A few examples of 45, 45, 90. So this is 45, 45, 90. So if this side length is 9 centimeters, what is this side length? 9 centimeters as well. However, across from your 90 degrees, your hypotenuse, what is your X value? Yeah. 9 root 2 because it's your side length times root 2. So we just tack on that 9 to root 2. That's it. Okay. Now, in B, you are given your hypotenuse, which is 5 root 2. So we know that equals root 2. We need to find the missing side length. Some of you could figure it out just by looking at it. Okay. Others, to find out what X equals, to find our two side lengths, we would divide by root 2. What happens to our root 2's? Cancel out. So what is our side length? Just 5. Okay? Questions? All right. Now if we look at C, we're given a whole number now. We have to find the missing side length. So since we are given our hypotenuse of 18 centimeters for 45, 45, 90, what does our hypotenuse equal? What's that measurement? Yeah. Good. So to find our missing side length, 18 equals X root 2. So how do we go about solving? What do we do first? Then? Any answer? What's your first instinct? What would you do? Not square it. How do I get X by itself? What do you think? Yeah. You would divide just by root 2. Okay? So we have 18 over root 2. Can you have a radical in the denominator? No. So how do I get rid of it? Oh. multiply by root 2 on each side. So I have 18 root 2 over 2. Can I simplify? 18 divided by 2 is what? 9. So our missing side length is 9 root 2. Okay? And it's okay if you have a radical on these side lengths. That's okay. Some people might see it and be like, oh no, that's supposed to be my hypotenuse. No, 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 no. Okay? All right? So I want you guys to give, let's see. I want you to give D a try first. We'll do the others together. Give D a try. All right. So we have a 45, 45, 90 here. 8 is one of the side lengths. What does N equal? 8. What does our hypotenuse equal? Go ahead, Mia. 8 root 2. Done. Okay? All right. We're going to skip E and look at F. We're given the hypotenuse, which is 3 root 5. What does our hypotenuse equal in a 45, 45, 90? Yeah, Tyler. So we have 3 times root 5 equals, right? X root 2 for now. Just for now, God bless you. Because that's what it equals, right? But we have to find the missing side length. So what do we have to do here? Okay. Divide both sides by root 2. So we have 3 root 5 over root 2. Can I have a radical in the denominator? No. How do I get rid of it? Good. So I know I have 2 in the denominator. What is in the numerator? Yeah, Rory. Excellent. 3 root 10 over 2. Okay, are we okay? A little bit? I know the radical stuff can be a little confusing at first. Okay? So, 45, 45, 90. Both side lengths are the same, right? Both side lengths are the same. Hypotenuse is side length times root 2. All right? Let's try 30, 60, 90s. All right, for our last thing, and then you guys are going to get some practice. You're doing great. Everybody is. All right. So remember, across from 30 is your side length. Across from 60 is your side length times root 3. Across from 90 is 2 times your side length. All right. So we're starting out pretty easy here. Across from 30 is our side length. That equals x. What would be across from 60? L. So instead of x, what am I going to replace it with? Good. 8 root 3. Excellent. Centimeters. And then across from 90, 16, because it's 2 times your side length. So that's 16. Excellent. Excellent, you guys. All right. Now what are we given in B? Are we given 30, 60, or 90? Which one? 60, right? So what does 60, what does that measurement supposed to equal? X root 3. So we set up the same way. 18 equals X root 3. How do we go about solving? Sounds like a broken record over and over again. Same thing. Go ahead, Mia.
Divide by root 3.
Divide by root 3. Can I have a radical in the denominator? No. How do I get rid of it? Go ahead. So we have 18 root 3 over 3. Can I reduce? Six root 3. Good. So 6 root 3 is my side length. What would my hypotenuse be? Liam? You are correct. 12 root 3, because it's 2 times this, and you only can multiply your whole numbers, right? So it's 2 times 6 root 3, which is just 12 root 3. All right? Last ones aren't bad. All right. For C, what are we given? 30, 60, 90. Which one? 90. So cross from 90 equals what? What is our hypotenuse measurement for 90? Go ahead, Tyler. It's 12, and then according to the measurement, what is it? Is it x root 3, or 2x? Nick? 2x. So that is equal to 2x. Divide by 2. What is our side length? What is across from 30? Go ahead, Luce. 6. Then if this is 6, what is across from 30? Go ahead, Luce. 6 root 3. Excellent. Okay. Good job, you guys. And then D, what's given to us? 30, 60, 90. 60, good. And what does 60 equal? X root 3, or 2x? All right. So if that is equal to x root 3, what is our missing side length? Go ahead. Good. 12 centimeters. And therefore, what is my hypotenuse? Good job. All right. Good. All right, you guys, there's 3 I want you to try on your own. These are all 60. Actually, 2. E and F. Okay, try E and F. We're going to check those in. All right, for E, we are given 60. Okay, so we know 9 equals x root 3. What is my side length? Emily? 3 root 3. Good. This is 3 root 3. So therefore, what is my hypotenuse? Go ahead now. 6 root 3. Excellent. How many of you did get that? Good. Okay. And then for F, we're given 60 again, which is 29 root 3, which is equal to x root 3. What is our side length? Nick? 29. And what is our hypotenuse? 58. Good. Excellent. Good job, you guys. Any questions? We went through a lot. However, a lot of it was recall, hopefully. Okay. You did go through a lot. All right. The biggest component of this, which we're going to see throughout this whole entire unit, is what we just covered. Okay. So your practice and your homework is, which are the last 2 pages. 6.1 practice. Okay. The first one goes through what we covered at the beginning. Okay. Then it goes through finding the missing side lengths. Then given the degree. Okay. Pretty much everything we have seen. Okay. And then we get into our special right triangles, which is a puzzle. Okay. So one thing with this, you cross out the correct answers. So you might get the correct answers multiple times, but if you cross it out once, that's it, okay? The remaining letters are going to spell out a term, all right? So you have the last 2 pages, 6.1 practice here in our special rights, okay? Yep. Yes, when you're finding an angle, it's the negative one, all right? Great job, you guys.